Oh wow, am I ever ready to lock in? Give full metal if you're ready to lock in. Yeah, all right. It's time to lock in for trig identities because this stuff is juicy. Okay, let's go for it. This is going to be great. I'm really excited to put all of our trigonometric ideas together. To not only prove, we're doing proofs today. So Charlie, you're going to remind your table that proofs require a more formalized approach than just presenting a solution. All right, so you're going to be in charge of like making sure that they're being more formal with their methods and following what I show. And also we're going to solve some equations using our trig identities. So we're going to put these back into like solving things. So when you have trigonometric identities and you want to like prove them, this should be how to prove. Okay? We must work with the left side and the right side separately. We can't move things across the equal sign to prove identities. So we do like a left side proof and a right side proof. Ideally, you just write things in terms of sine and cosine using your identities. And we have some new identities today that are based on double angles that are special cases of our compound angle theorems from a couple days ago. So let's go, everybody, lock in. We want to manipulate each side. Generally, if you just go like the simplest, and go for sine, cosine, you can get these to go. You can get these to work. And then simplifying expression rules using, adding fractions together, getting common denominators, factoring things to get things like into recognizable pieces. These are all strategies that we're going to use. And we want to keep looking at the two sides and working the two sides independently towards one another so that we're being strategic with our algebraic choices. Okay, for our proper notation, we're going to split them into left side, right side, and we show all of our steps. Every manipulation. Eva, do you mind just grabbing the door, tucking it closed? We're going to show all of the manipulation so that the reader will understand. It's a proof, it's not just a solution, so we're not just after an answer, we're after like rock solid proof. We don't just want to know, are they guilty or are they innocent? You want to prove it along the way. Okay, so once you're done, you can write, therefore the left side equals the right side. If you like to write a novel, you can do that and add to your NaNoWriMo word count. If you want to just go, therefore the left side equals the right side, you can do that. That's Miss Metherall's favorite. My favorite is just writing QED. Feels real fancy. Feels like we're doing fancy stuff when you write QED. That's Latin, everybody. It means I proved the thing that you wanted me to prove when you write QED. So that's what I do. Okay, so here are some of the identities that we had from last year. I came back from vacation and I already got a tan. You can get that tattooed on you and then you're always tanned. Okay, sine over cos is tan. All right. The reciprocal identities, well, we just remember that there's a co in each pair. So cosecant goes with 1 over sine, secant goes with 1 over cosine, and cotan is just flip tangent. All right? And then, so there's cotan, just flip tangent. No surprise there. Your Pythagorean identities are super useful. This is the only one I have memorized, to be quite honest. I never use this one or this one, but probably they could save me a step or two if I did. If you reduce to sine over cosine and you're good with fractions, you don't need those. You can always get that from this. But you kind of need that one memorized. Sine squared theta plus cos squared theta is equal to 1. And these can be rearranged. Suppose I have cos squared theta. Well, I could write that as 1 minus sine squared theta. That might be useful to me. Okay? And you can see that's just a simple reorganization of that one. Subtract sine squared theta from both sides. So the Pythagorean identity might be reorganized, and that might be useful to you. Okay, so that's all review. I see some people writing some stuff down, so I'll give you a second. Okay, carry on. Okay, so suppose we wanted to prove something like this. Well, I go left side is equal to cosecant, oops, that's weird, CSC. Oh, that's so weird. I'm not going to talk. I'm just going to write. My brain and hand are doing weird things.
Can I just do theta instead of x so it doesn't confuse me?
Sure. Yeah, that would be fine. And then I rewrite cosecant x as 1 over sine x. And then cosine x is just still out there. And that's equal to cosine of x over sine of x. Okay, looks like I've gotten that into terms of cosine and sine, so I can't go any further with that. Now I work on the right side. Lo and behold, it's cotan of x. And cotan of x is just flipped tan, so I check my tattoo, and I find that that's equal to cosine of x over sine of x, which equals the left-hand side, QED. And I feel fancy. Yeah. All right. Good. Let's keep going. Whee! Wait. No? Oh, okay. I just wrote down what they are in terms of sine and cosine. They happen to be the same thing. Maybe I struggle with fractions, so I could write the cosine x over 1, and then I have cosine 1 times cosine x and sine x times 1, right? Because I remember this is multiply, and I multiply top times top over bottom times bottom. Okay, keep going? Yeah, let's keep going. Tan x sine x equals secant x minus cosine x. Ooh, we got some addition, subtraction on one side, and some multiplication on the other side. Interesting that these are purportedly the same things. I thought you were sharpening a pen for a second. Okay, so I go left-hand side equals. You can do these on your own too. So I change that one up. And I'm going to be multiplying by sine x here. That's sine x over 1 for those who want to know. So this is a fancy way of saying sine squared x over cosine x. That's as simplified as I can get the left-hand side. Let's see what the right-hand side gives us. Secant x is just 1 over sine. No, it's 1 over cosine x. Oh, man. Can you grab that for me? Tell them I'll be there in just a moment.